Hello everyone, this is Vipul Purohit and I welcome you to the another session of Chemistry Practicals. Here I am going to discuss about the theoretical approach of an experiment, the aim of that experiment, the title of the experiment you can read out. Yes, my dear friends, it's all about determination of the velocity constant of the alkaline hydrolysis of ethyl acetate by conductometry. So you can understand now that this is an experiment which is a combination of a theoretical concept which is based on chemical kinetics. Okay, because we talk about velocity constant, so it comes into chemical kinetics. And when we talk about chemical kinetics, the first thing which comes into our mind, the most important parameter which is going to dominate it, and that is time. Next thing is we are going to carry out this analysis by conductometer. And that means it's instrumental as well. So it's a combination of both a non-instrumental with an instrumental part. Alright? So, to begin with, before I explain you the procedure of this experiment, I'll first of all give you the insight about what is the theory behind this experiment. Alright? So we begin with alkaline hydrolysis of ethyl acetate. My dear friends, ethyl acetate is an ester. And when alkaline hydrolysis of an ester takes place, it is also called as, oh yes, you guessed it right, it's saponification. Okay? So that's the first point that you need to keep in mind, my dear friends. Alkaline hydrolysis of an ester is known as saponification. Okay. Now in this particular experiment, the ester that we are going to take is ethyl acetate and the alkali that we are going to use is sodium hydroxide. So the reaction is CH3, C double bond O, C2H5 along with NaOH, sodium hydroxide, which is aqueous. So that's why I call this as alkaline hydrolysis. It results in the formation of CH3, COONA, so it's sodium acetate, and you get ethanol, C2H5OH, ethanol. This is a reaction, my dear friends. This is what we call it as what? Saponification as well. Now if you try to understand this reaction very well, what happens is, the rate of this reaction depends on the acetate ions as well as the hydroxide ions. It depends upon both. Okay, this is the acetate ion which I am talking about, CH3CO minus, and this is the hydroxide ions which I am talking about. Okay, so it depends upon both these ions, and therefore we say that alkaline hydrolysis of an ester is called or is going to follow a second order. Okay, so it's a second order reaction. Whenever the rate of the reaction depends upon concentration of two species, then we call it as what? A second order reaction. So my dear friends, this is a second order reaction. Alright? Next, because my dear friends, that this is also related to conductometry. Okay, so we talk about measurement of conductance. So we need to understand that how is going to the conductance values varying with the progress of this reaction. So let me tell you over here, and that is the fast moving hydroxyl ions are replaced by slow moving acetate ions. The speed of the ions differs now. Okay? And speed of the ions differs, so obviously it will have an effect on the value of conductance. Hydroxyl ions, they are fast moving ions. तो obviously उसका conductance ज़्यादा है. Because conductivity is all about flow. तो जिसका flow ज़्यादा, उसका conductance value भी ज़्यादा है. यानी OH माइनस का कंडक्टेंस ज्यादा है, एसिडेट आयंस का कंडक्टेंस कम है. और वो OH माइनस रिप्लेस हुआ है बाय व्हाट CH3CO माइनस। तो जाहिर सी बात है हायर कंडक्टेंस वैल्यू एन आयन विद अ हायर कंडक्टेंस वैल्यू इज रिप्लेस्ड बाय एन आयन विद अ लोअर कंडक्टेंस वैल्यू। तो जाहिर सी बात है इससे क्या होगा कि देयरफॉर द कंडक्टेंस डिक्रीजेस। ओके, कंडक्टेंस विल व्हाट डिक्रीजेस विद टाइम, क्योंकि विद टाइम व्हाट हैपेंस इज द रिएक्शन प्रोसीड्स टुवर्ड्स द राइट हैंड साइड। So more and more amount of sodium acid is formed. ज्यादा से ज्यादा मात्रा में हाइड्रोक्साइल आयन रिप्लेस हो रहा है एसिटेट आयन से, और इस तरीके से वक्त के साथ कंडक्टेंस के वैल्यू में कमी दिखाई देगी। ओके, आई होप ये कंसेप्ट आपको समझा। नेक्स्ट थिंग इज हमें वेलोसिटी कांस्टेंट फाइंड आउट करना है। ओके, वी हैव टू फाइंड आउट द रेट कांस्टेंट। मैंने आपको ऑलरेडी बोल दिया कि द रिएक्शन इज अ सेकेंड ऑर्डर रिएक्शन। ओके, तो सेकेंड ऑर्डर रिएक्शन के हिसाब से वी आर गोइंग टू कैलकुलेट यूजिंग द फॉर्मूला एंड दैट इज K इज इक्वल टू 1/T इंटू x अपॉन A इंटू A माइनस ऑफ x। ओके, दिस इज व्हाट वी आर गोइंग टू कंसिडर। ओके, ये पर्टिकुलर फॉर्मूला हम यूज करेंगे। ओके, where T stands for time, okay, x a and a minus of x stands for concentrations. Okay, तो एक concentration term cancel होगा by the another concentration term। तो जब हम units की बात करेंगे, the units of K will be now considered as what? Concentration gets cancelled, so we have 1 upon time into 1 upon concentration. So therefore we say concentration inverse, time inverse. Okay, this will be the units of K, that is the velocity constant for a second order reaction. Okay, so ये था दोस्तों the theory behind this particular experiment. Okay, and I hope you have understood this very well. Alright, my dear friends, once you have understood the theoretical background of this particular experiment, we move on to the next part, and that is, yes, the procedure. I'll explain you step by step the procedure so you get the entire gist of this particular experiment. Okay, so we begin with step number 1 is in the procedure part. The first step, burette is filled with 0.05 normal NaOH. Okay, burette is filled with what? 0.05 normal NaOH. Okay, that's point number 1. Point number 2 is 20 cm³ of the supplied, approximately it's 0.05 normal acetic acid, is prepared in a conical flask. Okay, in a conical flask. My dear friends, please be clear. It's a supplied acetic acid. Okay, so 0.05 normal is an approximate one, because it's very clear that if you know the exact normality of both the solutions, then why are we going to carry out the titration in the first place? समझ में आ रहा है ना आपको? Okay, तो NaOH का concentration is fixed. Okay, it's a standard solution. ऐसा solution जिसका concentration मुझे मालूम है उसे मैं क्या बोलूँगा? Standard solution. Okay, तो वो 0.05 नॉर्मल है। अगर एसिडिक एसिड भी अगर मुझे मालूम होता कि ये एग्जैक्ट है तो फिर मैं टाइट्रेशन करने की कोई जरूरत ही नहीं है, क्योंकि 20 ml of 0.05 normal acetic acid will correspond to 20 ml of 0.05 normal NaOH. Okay, लेकिन ये सप्लाइड है दोस्तों, सो उसका एग्जैक्ट नॉर्मेलिटी आपको नहीं मालूम, सो प्लीज कीप दिस इन माइंड. ओके, सो सेकेंड स्टेप में 20 cm³ ऑफ द सप्लाइड एसिटिक एसिड इज प्रिपेयर्ड इन अ कॉनिकल फ्लास्क, जिसमें आपको ऐड करना है 2 to 3 drops of phenolphthalein indicator, and normally the concentration of the indicator is how much? 1%. ओके, सो 1% ऑफ फिनोफ्थैलीन इंडिकेटर आपको डालना है उसमें, और फिर क्या करना है, आपको टाइट्रेट करना है. ओके, टाइट्रेट. एंड पॉइंट तो अभी आपको आइडिया होगा ही. इनिशियली सी, कभी भी हम टाइट्रेशन करेंगे तो इंडिकेटर हैज टू बी एडेड इन अ कॉनिकल फ्लास्क. In a conical flask, there is an acid. In the acidic medium, the phenolphthalein indicator has a very low sensitivity. What is sensitivity? Is response to change. Okay, तो acidic medium में वो sensitive नहीं है, मतलब वो respond नहीं करेगा to any of the changes. यानी phenolphthalein colorless है, तो acid में डालने के बाद भी वो colorless ही रहेगा. In the basic medium, okay, it is going to show very high sensitivity, and therefore जब NaOH में डालूंगा from the burette, which is a base, then it is going to show the response in the form of a color change, and therefore we say end point will be phenolphthalein is colorless. So in the acidic medium also it is going to remain colorless. So colorless to pink. Okay, this is going to be the end point. Note this reading. As x cm cube of 0.05 normal NaOH. ठीक है, note this reading as what? X cm cube of 0.05 normal NaOH. ठीक है, अब नेक्स्ट क्या करना है? Once again, we take 20 cm cube of 0.05 normal एसिडिक एसिड, लेकिन इस बार हमें लेना है उसे इन 100 cm क्यूब स्टैंडर्ड मेजरिंग फ्लास्क. ओके, 100 cm क्यूब का स्टैंडर्ड मेजरिंग फ्लास्क आता है विद अ मार्क, तो उसमें आपको लेना है. इन द प्रीवियस केस यू हैव टेकन इट इन अ कॉनिकल फ्लास्क, बट दिस टाइम यू आर गोइंग टू टेक इट इन व्हाट? स्टैंडर्ड मेजरिंग फ्लास्क. इनटू दिस add x cm cube of 0.05 normal NaOH and dilute up to the mark with distilled water. Okay, mark मतलब 100 cm cube. Okay, with what? Distilled water. समझ गए? वापस से बोलता हूँ. 20 cm cube of acetic acid has to be taken now in a standard measuring flask, into which you are going to add x cm cube of 0.05 normal NaOH. Now you guys must be having a question, so what do you mean by x cm cube? X cm cube is this volume of NaOH which is required to neutralize 0.05 normal 20 ml acetic acid. Okay, जो हम लोग ने पहले टाइट्रेशन किया था. Okay, तो जितना इधर वैल्यू आएगा उतना हमें वॉल्यूम ऐड करना है. And dilute it up to the mark with distilled water. तो हमें क्या मिलेगा? This will give me 100 cm cube of 0.01 normal sodium acetate. Okay, this is going to give me what? 0.01 normal sodium acetate. Note the conductance. Or it will be denoted as G infinity. Okay, note the conductance as what? G infinity. अभी क्या कीजिए? Note the conductance of 0.01 normal NaOH as G0. ओके, तो दो कंडक्टेंस वाले आपको लेना है. पहले तो वापस से बोल देता हूं. वी आर गेटिंग 100 cm cube of 0.01 normal sodium acetate. So transfer it into a beaker. Okay, around say 50 ml is sufficient. Okay, till the bottom part of the electrode of the conductometer should dip in the solution. Okay, that much is required. So we are not going to exactly measure it. Okay, तो एक छोटा सा बीकर लीजिए, उसमें वो ट्रांसफर कीजिएगा जो हम लोग ने बनाया 100 cm cube of 0.01 normal sodium acetate. नोट डाउन द कंडक्टेंस वैल्यू. जो कंडक्टेंस वैल्यू आएगा उसको हम डिनोट करते हैं कैसे? जी इन्फिनिटी से. फिर एक और बीकर लीजिए, उसमें आप लीजिए 0.01 नॉर्मल NaOH. एग्जैक्ट है. ओके, एग्जैक्ट नॉर्मेलिटी. ओके, 0.01 नॉर्मल NaOH. Volume, as I already told you, till the bottom portion of the electrode must dip into the solution, that much you are going to take. And note down the conductance value, और वो conductance को कैसे symbolize करेंगे as G0. तो G infinity is the conductance of 0.01 normal sodium acetate, okay, and G0 is the conductance of 0.01 normal NaOH. Okay, यहाँ तक समझ में आया? आगे और भी थोड़े steps है, लेकिन मुझे बताइए, okay, just go through all the steps and just check it out whether you have understood up to this very well. Okay, now we move ahead now with the procedure, and that is we now talk about the reaction kinetics. Now in reaction kinetics, my dear friends, what we do is we take a beaker, okay, which is being filled with 5 cm cube ethyl acetate plus 25 cm cube distilled water. Okay, we take another beaker, this is filled with 20 cm cube 0.05 normal NaOH and 50 cm cube of water, and of course it is distilled water. Okay, and the entire assembly is being placed in a water bath. Okay, the entire assembly is placed in what? Water bath to attain the room temperature. This is a water bath to attain what? Room temperature. Okay. Now, once it attains room temperature, say around 10 minutes is sufficient. Now what we do is mix the two contents of the beaker. How to mix is this way. Okay, mixing is in this way. That means the NaOH solution will go into ethyl acetate. Okay, and note the time of mixing. Okay, whatever is the time, that please you note it, because as I told you, chemical kinetics hai. So time plays a very important role. And then note the conductance of the solution. This one, okay, ये बीकर तो खाली हो जाएगा अभी. Okay, तो सब कुछ इसमें होगा. ये कितना है टोटल? 30 ml है, और ये टोटल कितना हो जाएगा? 70. Okay, so that means total will be 100 cm. तो ये जो बीकर है, ओके, उसका कंडक्टेंस वैल्यू हमें नोट करना है. सो नोट द कंडक्टेंस एट इंटरवल्स ऑफ 5 minutes till 30 minutes from the time of mixing, and these readings are being denoted as GT. Okay, these are denoted as what? GT. So G infinity क्या था? It was the conductance value of 0.01 normal sodium acetate. G0 क्या था? Conductance value of 0.01 normal NaOH. And GT are the different conductance values at every intervals of time. 5-5 मिनट के अंतराल पे आपको रीडिंग लेना है. यानी अगर आपने दोनों सॉल्यूशन को मिक्स किया से 8 बजे, तो आपका पहला रीडिंग होगा 8:05 को, फिर 8:10, फिर 8:15, फिर 8:20, फिर 8:25 और फिर 8:30. So this way 6 readings we have to take at intervals of 5 minutes. So it comes out to be what? 30 minutes. And those readings are being denoted as what? GT. Okay? अब अगर आपको याद है, मैंने आपको जब theoretical background explain कर रहा था, that time I had given you the formula of the velocity constant for the second order reaction. Okay, तो इसमें मैं आपको बताना चाहता हूं, when I talk about small a, it is G0 minus G infinity. When I talk about x, it is going to be G0 minus of GT. और जब मैं a minus of x की बात करता हूं, so it will be G0 minus G infinity minus of G0 minus minus plus होगा तो this will be GT. Okay, तो G0 and G0 gets cancelled. तो क्या बचेगा फिर GT minus of G infinity. Okay, और मैं आपको वापस से लिख के देता हूँ the formula for the reaction constant and that is 1 by T x upon A into A minus of x. Alright, my dear friends, this is what is the formula for the rate constant for the second order reaction. What is x? I have already written. What is A? That also I have written. A minus of x also I have written. Alright, we have already got those values. So just substitute in these values and you get the specific reaction constant, or what we call it as a velocity constant for the alkaline hydrolysis of ethyl acetate. And because we are doing it on the basis of this formula, is being converted in the basis of what? Conductance. And conductance, how we are going to measure it? Oh yes, it's by a conductometer, and therefore this is by a conductometric experiment. Alright, so this is, my dear friends, the entire theoretical approach of this particular experiment. I am sure you have understood this, and if you have understood this, then definitely you will interesting it. Okay, you will find this very interesting, as I found it interesting in presenting in front of you. So thank you so very much.